Hi, welcome back to the Math Resource Showcase. I'm Amber Soto, and today we're going to go over the solution from a fraction problem that was posed previously from mathsolutions.com. So we're going to come back here to mathsolutions.com. We're going to click on this Explore Resources button, and then we're going to scroll on down to grades 5 and 6 right here, and then we're going to look at the fraction problem. Now, what we had looked at was using the digits 1 through 8 only once. Place one digit in each box and it can't be a repeated number. Now, you're not going to obviously use all those numbers 1 through 8. That's 8 numbers. You're only using 4 of them. There's only 4 boxes, but you can't repeat it, and it has to be one of those numbers 1 through 8. Okay, and so then the parameters were, what is the least possible product? What is the greatest possible product? And how did you make your number choices? So we got quite a few responses to this, and so I really like kind of bringing people in that are responding, because I like to have this be interactive. So what I want to do right now is I want to share with you some of those responses. So we're going to start with Sophie from Texas. So let's see what Sophie from Texas had to say.
So here's my biggest 56 halves, which equals out to about 28 wholes, or 228 wholes. And then we have 1/7 times 2/8 equals 256, which is the smallest you can get using these numbers. Okay, those are my fractions. Thank you.
Thank you, Sophie. We also heard from Neil, who said 7 and 8 over 1 and 2 for the greatest, and 1 and 2 over 7 and 8 for the lowest. And we heard from Karina, who said 8 over 1 times 7 over 2 equals 28. I think she's assuming for the greatest, or 7 over 1 times 8 over 2 equals 28. And then also flip the fractions to get the smallest. So she got 0.0357. All right, so I guess the point is everybody's kind of trying to say the same thing. So let's quantify this a little bit. When you're multiplying fractions, you just multiply straight across. And what you need to know about a fraction is the greater the numerator, or the number on top, the greater the overall value is. And for the denominator, it's the opposite. The bigger the number is on the bottom, the smaller the overall number gets. And so when you're looking for the greatest possible value, you're going to want the greatest possible numbers on top, and then the smallest possible numbers on the bottom. So remember that multiplication is commutative. So whether you choose 8 for this one and 7 for this one on top, or flip-flop it, 8 times 7 and 7 times 8 are the same thing. And the same thing for the numbers on the bottom, the denominators. You're going to want 1 and 2. Whether you choose to do 1 times 2 or 2 times 1 will come out to the same thing. So what you're going to end up with on top for the greatest value, 7 times 8 equals 56. 1 times 2 equals 2 on the bottom. And 56 divided by 2 is 28. So that is the greatest possible value that you can come up with using those parameters. The same thing, you flip it for the least possible value. You want the greatest numbers now on the bottom, and you want the least numbers on the top. So you want 1 times 2 on the top, or 2 times 1, and then you want 7 and 8 on the bottom. So you'll come out with 2 over 56, which will reduce to be 1 over 28 for your least possible value. All right, that was a lot of fun, but I think that the next challenge that I have for you, it's one called Gabriel's problem, is one that's going to take a little bit more digging into. So I think it'll be a lot of fun. Thank you so much for participating. Thank you so much for joining me in this process. I really hope you're enjoying these as much as I am. I hope you're making connections, and I hope you're having a good time. Have a beautiful day today, and happy mathing.